Hi, in this video we will have a brief overview of SIESTA compilation options. Since there are many possibilities, we will assume that after weighing whether you want to build SIESTA yourself or have someone build it for you, you have decided to do it on a Linux machine. Detailed instructions exist for all platforms and many more cases. In this video we will concentrate on 3 examples. My name is Yann Pouillon, I am an engineer and PhD, and I have contributed over the years to various software packages, with an emphasis on build systems and distribution strategies. I am a co-founder of the Electronic Structure Library, which is an initiative to distribute software among the electronic structure community. I am currently working at Simune Atomistics, a small company that distributes software and provides services around atomistic simulations. Simune is interested in both industrial and academic users and directly contributes to various open source software packages. Among the services we provide, there are precompiled SIESTA binaries. Let's now start. First, I would like to emphasize that building software is not just transforming source code into binary code, but there are many things around which are involved in the success of the whole process. So first, you have to prepare the environment, then configure the build, then produce the executables, then install them or put them somewhere where they can be used, and finally run the executables in the correct environment. We will now explore 3 examples. The first one is to build a version of SIESTA 4 manually, and we will give more details in this case. So, preparing the environment is a step that is not specific at all to the software you want to build. What we will do here is valid for almost all DFT codes. This is really critical if you want to have a successful build, and it is mostly organized around a list of requirements that you need to have before you can build SIESTA in this case. Also, what is very important to know is that this is something that you have to do at most once or twice a year. So this is not something that you need to do before each build. To build SIESTA 4, you will need a C compiler, a Fortran compiler, the GNU Make utility, an MPI distribution if you want to build a parallel executable, linear algebra libraries, and then if you want platform independent input-output, then you will need HDF5 plus netcdf. There are many ways to install these requirements. On Linux, you will use a package manager. On macOS, you might want to use Homebrew. And on Windows, there will be a ad hoc way of installing things. You can also choose through different build frameworks. So through the console, for manual builds, this is what we will do now. From scripts and recipes, once you know how to do things, then you can streamline your builds and have a repeatable way of doing them. Docker containers, Singularity containers, and frameworks like EasyBuild or SPAC. You can also use virtual machines, mostly for testing and learning, just as you have in this school. As usual, detailed instructions are available in the SIESTA documentation. Once we have a proper build environment, we have to decide which kind of SIESTA executable we want to build. So serial or parallel, which compiler do we want to use, which MPI distribution will we use if we want a parallel SIESTA executable, which set of linear algebra libraries, this depends a lot on the compiler you want to use, and with or without platform independent I/O, so netcdf, this will depend a lot on what will be done with when executing SIESTA. Once we have made these choices, we have to translate them into an arts.make file. This is the main configuration file for the build of SIESTA. So detailed instructions are in the documentation. We will not cover them here. And then the last step is to copy the files from src into the object, the subdirectory that is used for the build of SIESTA. In order to make sure that you have done everything correctly, I always recommend to type make clean before doing anything else. For the build itself, if you want to build SIESTA 4.0 or if you don't want to use too many resources on your machine, just type make. Then if you have a machine with multiple cores or if you are building on an HPC cluster, the recommended way is to use make -j. So make -j4, for example, will use 4 processes at once to build SIESTA when possible. So this is only valid for SIESTA 4.1 or later versions. With SIESTA 4.0 you can expect a few issues. Then you wait until the build finishes, and if you type ls-ltr, then you will see a list of files, and SIESTA should be the last one. So in case the build fails when you are after typing make -j, type make again without any option. This will help you to find more easily where the error occurred. Once you have built the SIESTA executable, you can go through an extra step and by going to the util subdirectory and build some utilities there. So, for example, if you want to build the GNU bands utility to plot band structures with GNUplot, you go to utils band and you type make again, and you will see that the GNU bands executable is produced. Then you can do it again for any other utility you will like to use afterwards. Now that you have SIESTA and some utilities built, a very good practice is to copy the executables outside the source package. So, for example, you could create a directory in your home named SIESTA 4.1 bin, if after building SIESTA 4.1, for example, and there you will copy the SIESTA executable and all the utilities that you have built there. To make sure then that you can access these executable easily, you can write also a simple script in the same bin subdirectory that we will call here siestavars.sh, and this script will update the path to make the SIESTA executable available. If you have followed all these steps, then you will be able to run SIESTA with the correct environment always. So basically that will mean use the siestavars.sh file. So if we will suppose that you're using a Bourne compatible shell, so like bash. And in this case you would write source $home SIESTA 4.1 bin siestavars.sh, and this will update your environment so that SIESTA is directly accessible to you. You have to do it only once per terminal session. So every time you spawn a shell, this has to be done once. And also every time you run SIESTA from a script, this should also be done before. The advantage is that it will keep your default environment always clean. And remember, so there are detailed instructions in the SIESTA documentation. In our second example, I'm now showing how to build SIESTA 5 with the ESL bundle. Contrary to SIESTA 4, SIESTA 5 comes without all the dependencies included in the source package. And this is why the ESL bundle can be useful. So what is it? So this is a curated collections of libraries that are used to build various DFT codes, not only SIESTA. It only provides components related to electronic structures. So explicitly excluded are linear algebra libraries, mathematical libraries, I/O libraries like HDF5, netcdf. So this has to be installed in a different way. So as we said before. The advantage is that you can use the same up-to-date set of libraries to build SIESTA and other DFT codes. And it provides 1 or 2 releases per year, so which is perfect with to update the environment once or twice per year. So to download it, you have to go to GitLab, and in the electronic structure library repositories, you will find the ESL bundle. So how to use it? Here is an example. I will suppose that you want to compile the libraries on Ubuntu with GCC and OpenMPI, because you want a parallel build of SIESTA. So first you will clone the ESL bundle, get there, create a build directory, and then call the main install bundle script of the ESL bundle with a few parameters. In this case, -s Ubuntu means system Ubuntu, -c GCC for the compiler, and -f flavor OpenMPI for the variant using OpenMPI. So the ESL bundle comes with a set of pre-configured files, and Ubuntu GCC OpenMPI is one of them. Then you wait until the build finishes, and the components will be installed in a subdirectory named install. Yeah, just be careful when you compile recent libxc versions, because this could take quite some time. The ESL bundle will produce a series of libraries and executables, and to access them, then you will need to add some variables to your environment. So these are mainly LD library paths for the libraries and updating the path for the executables. Of course, after you compile SIESTA, you will also have to add these lines to your SIESTA vars.sh file. And then to compile SIESTA is the same as what we explained for SIESTA 4. So you create an arch.make, you finish the configuration, and then you make the executable and copy it to a directory of your choice. In our third example, we will build any SIESTA version with EasyBuild. So EasyBuild is a framework which is optimized for reproducible builds, and this is used a lot in HPC clusters. So the first thing you have to do when building something with EasyBuild, you have to choose a location where you will install all the software packages. And be advised that you will need something like between 10 and 20 gigabytes free, because EasyBuild will build everything from the compiler to the latest library you need. So before using EasyBuild, you need to make sure that you have at least installed GCC, Lmod, which is a module manager, and that you have Python 3 installed on your computer. To install EasyBuild, this is very easy. So you just pip install EasyBuild, either directly in your environment or better in a virtual environment, and then you configure it. So the config file should be located in .config EasyBuild directory in your home, and you can use your preferred editor to edit the file. Then what do you put inside? So the following sections. So there is a section called basic, where you tell EasyBuild to put repositories and etc. So here we will suppose that you want to install everything in opt HPC on your computer. Then the configuration itself of EasyBuild is telling, so use Lmod to manage the modules. and use the opt HPC prefix to install the software. Then we have a little trick which with the override section which will avoid errors with download timeouts, because some servers sometimes are slow to download the source codes of the packages. So yeah, a general advice is, before starting, make sure that if you use opt HPC as a destination directory, that you can actually write in it. EasyBuild provides toolchains. So these are consistent sets of compilers and libraries. This is critical for reproducibility of the builds. Since when EasyBuild publishes a new version, it takes time to produce these sets. I recommend avoiding the selection of the latest toolchain, because you will have to make yourself the recipes to build your preferred libraries and executables. So what I usually do is to use the toolchain from 1 year ago. And in our case, for example, we could use the GOMPI 2020A, which means GCC with OpenMPI, published in the first half of 2020. To make the toolchain ready, you just type eb gompi-2020a.eb, and -r means recursive, so it will install everything it needs to have the toolchain working. Okay, just one piece of advice: take your time. So probably it's better that you do it on a night and you leave it for the whole night working, because it can take between 3 and 7 hours. And the good news is that you have to do only this once per toolchain, so once or twice a year. So once you have a toolchain, you can now install common SIESTA dependencies. So one thing is the linear algebra libraries, and so if you don't know which recipe to install, you can search for it. So with eb -s and a keyword, you will find the different packages you need. So for linear algebra, you will need Scalapack, since we are using OpenMPI, and so EasyBuild will tell you that there is this Scalapack 210 GOMPI 2020A recipe available. The same for NetCDF. SIESTA is in Fortran, so we need a NetCDF Fortran implementation. And if you build it with EasyBuild, it will take care of building everything: HDF5, the C version of NetCDF, and then the Fortran version of NetCDF. For libxc, the same. You have various libxc packages available on EasyBuild, and in this case, you just have to adapt a little bit. It's so the GOMPI toolchain is using GCC 9.3, and so this is the one that you have to use for libxc. Once you have these common dependencies installed, then you can go to the specific dependencies of SIESTA 5. So for this, the ESL provides a repository of easyconfig files, and you can use it to build libraries like XMLF90, libpsml, or libgridxc. Before compiling SIESTA, you need to access the components that have been installed. So EasyBuild builds modules, and modules in the sense of lmod. So to know what modules are available, you just type module avail and you will get a list. And then to load the modules you need, you will type module load, the name of the module, or module load, the name of the module, and a specific version if you want to be more precise. Once this is done, then you can build SIESTA as we explained in the SIESTA 4 case. To summarize, whatever the option you choose to build SIESTA, you will have to follow 5 steps. So, prepare the environment, configure the build the executables, install them, and then run them in the correct environment. Detailed instructions are available on the SIESTA website, and they include additional steps like testing before installing the executables. So if you want to do an exercise, you can try this process and then make scripts that perform the workflows that you have chosen. Thank you for your attention.